Hello G, in this video I will solve all the MCQs of all variants of 2023, all the MCQs of electricity. So we will all MCQs of 7 papers, 3 variants of May, June, 3 October, November, and 1 March. So let's get started. So we have started with the first paper this is our sequence. October number 2023, paper 1-1, then 1-2, then 1-3, then May, June, paper 1-1, 1-2, 1-3, then Feb, March. So the first MCQ is the current I in VQ. What does the letter N represent in this equation? It's very simple, straightforward question. It is based on fact. You should know that N is the number of charge carriers per unit volume. N is number of charge carriers per unit volume. So very simple. What is A? A is cross-sectional area. What is V? V is average drift speed. In Q is the charge carried per charge carrier. I is the current. So the second question is the circuit shown the battery has EMF of 6 volt and negligible internal resistance. 3 resistors each have resistance R. You can see in the diagram where this battery is connected and these resistors are connected in this way. So the total power dissipated in a resistor network is this 24 watt. So we have to find what is the value of R. So I will recommend you to stop the video and do it by yourself so that your practice is not compromised. So I hope you have done this question. You have thought about that. So we are given the total power dissipated in the resistor. So we have three formulas of the power, that is I square R, V square over R, and VI. So which formula we are going to use? As we know, we are given EMF of the source, and we have to find the total resistance first, then we can find the value of R. So we will use this second formula. Okay. So the power is V square divided by R. This R is the total resistance. The power is 24 and V is 6, that is EMF of the source, 6 square divided by R total. So first find this R total, which is equal to 36 divided by 24. You will get this R total from this expression. Let's say this R total is represented by this sum box. Now look at this diagram and see how these resistors are connected. You can see these two resistors are in series and the result is in parallel with this resistor R. So what is R total in terms of R? R total is these two resistors will give you 2R, and 2R will be parallel with this R. So R total will be, if you have only two resistors, you can use, they are in parallel and you can use product over sum. So 2R time R divided by 2r plus r. So that gives you 2r square divided by 3r, which is r total is 2 by 3r. You will find r total from this expression that you already know, which is 36 divided by 24 is 2 by 3r. So r will be 3 times 36 divided by 24 times 2. This will be equal to r, which is equal to uh, 8. So 18 by 8, you can use your calculator to find this, and this is 2 by 3 ohm. I will not waste your too much time on these calculations. I will give you the basic idea and then you will be able to find it. So which graph could show the resistance R of a filament lamp varies with applied potential difference, where V is increased to the normal operating potential difference? What do you know about filament lamp? The resistance of filament lamp increases as voltage or current are increased. So if voltage is increased, its resistance will increase because the temperature will increase. So looking at these four graphs, you can see in, in this case, the resistance is constant as V is increased, so that is not possible. In this case, the resistance decreases as V is increased, so that is also not possible. In A and B, resistance increases as V is increased, but what is the difference? If there is no potential difference, the resistance R in this case is 0. If you apply no potential difference across filament lamp, it should have some resistance. It shouldn't have 0 resistance, so that's why B is not possible. In A, if the potential difference across filament length is 0, there is some resistance. But as you increase voltage, the resistance of the filament lamp increases. Don't try to mix this graph with V over I graph in case of filament lamp. If you have V over here and I in this over here, then the gradient of this graph will represent resistance and the gradient should increase and then the graph would be like this. Okay. But if I is on vertical axis, V is on x-axis, then resistance is 1 over gradient. The gradient is 1 over resistance. So the gradient should decrease. So many students mix this question and with these graphs and they get option B, which is incorrect. A piece of conducting putty is in the shape of cylinder of length 60 millimeter and diameter 20 millimeter. The resistance between the ends of cylinder is this. What is the resistivity of the putty? So we are given this resistance, we are given length, we have diameter, we have to find resistivity. So you should know this formula. R is equal to rho L divided by A. Resistance of a wire varies with length and cross-sectional area in this way. So we have to find the resistivity, which is this rho. So let's make this resistivity subject R A divided by L. So what is the resistance of the wire? That is 20. What is the cross-sectional area? We are given diameter. So the cross-sectional area of the wire is, the wire cross-sectional area is in circular form and the area of a circle is pi d square by 4. So please convert this diameter into meter and length also into meter. So calculate area from this expression. pi by 4. D is in 20 millimeter, that is 20 times 10 power minus 3 whole square. That is area, cross-sectional area of the wire. Put that area over here and then divide the whole expression with length, which is 60 millimeter. That is 60 into 10 power minus 3. Then you will get the answer of the resistivity in ohm meter. That is 0.1 ohm meter. Which statement about the EMF of a cell is always correct? EMF of the cell is always correct. The EMF is energy converted from electrical to other forms in the cell. You know, EMF is the energy converted from electrical to other forms. Uh, Electrical to other forms, that is potential difference per unit charge. And EMF is energy converted from other forms to electrical per unit charge is EMF. So that's why A is incorrect. The EMF is energy provided by the cell per unit charge, energy per unit charge provided by the cell passing through it. So that's why B is correct. The energy that 1 coulomb charge gets from the source is known as EMF. The EMF is potential difference across the internal resistance of the cell. No, the potential difference across the internal resistance is energy lost per coulomb charge inside the battery. EMF is the potential difference across the terminals of the cell. So now EMF and the potential difference both have unit of joule per coulomb. 35. Kirchhoff's first and second laws are consequence of conservation of which quantity? Very simple. First law, what is first law? At any point, sum of current entering to a point is equal to sum of current leaving that point. So, this is the application of consequence conservation of the charge. If the current entering to a point is equal to the current leaving that point, then that is only possible when charge is conserved. If charge is lost or gained, then that is not possible. So the Kirchhoff first law is the law of conservation of charge consequence. And what is second law? Second law states in a closed loop, sum of EMF is equal to sum of potential difference. Potential difference across this resistor is V1 and across this resistor is V2. So in this closed loop, sum of EMF is equal to sum of potential difference. And this is the conservation of energy. So the first law is the conservation of charge and the second law is conservation of energy. Okay. So 1 coulomb charge, for example, if this EMF is 10 volt, then 1 coulomb charge will get 10 joule of energy from the battery. And if let's say this V1 is 4 volt and this is 6 volt, then this 1 coulomb charge will transfer 4 joule of energy to this resistor and 6 joule of energy to that resistor. Very simple. 36. A circuit contains a cell of EMF E and internal resistance R. This dotted line shows the total, the model of cell. And this is external resistor, R is connected across this cell. Which equation is correct? So we have to use the second Kirchhoff's second law, Kirchhoff voltage law. That states that in a closed loop, sum of EMF that is equal to E, only single E, is equal to the sum of potential difference across this R plus sum of potential difference across this small r. So, if we rearrange this equation, we will get E minus IR is equal to IR. So A is correct. E is, second one is IR minus IR, E plus IR, E is equal to IR. So this is simple application of Kirchhoff's second law. In other words, you can think in this way, these two resistors R and R are connected in series. So the total resistance of this circuit is R plus R, and total EMF is this E. So the total current is E divided by R plus R. So if you will rearrange this equation, you will get this equation. A potential divider consists of two resistors R1 and R2 connected in series across a source of potential difference Vn. This is source, and these two resistors you can see from the diagram, they are connected in series. The potential difference across R1 is V out. You know the formula of potential divider, that is voltage across R1, V output is this R1 over R1 plus R2, the total resistors in this circuit in series. If there are three resistors, then you will add all of these three in the denominator times input voltage. Okay, so what we want to do, which changes to R1 and R2 will increase, this is important word. We want to increase this output voltage, and that can only be increased by increasing this resistor R1 or by decreasing this resistor R2. The voltage across R1 and R2, the ratio of voltage across R1 and R2 is equal to the ratio of their resistance. So let's say V output is voltage across R1 and this is voltage across R2. That will be equal to R1 over R2. So if you want to increase this, you have two possibilities. Either you can increase this R1 or you can decrease this R2. If you will decrease this R2, denominator will decrease. So as a result, V output will increase. If you will increase this R1, numerator will increase. R1 is also there in denominator, but increasing R1, for example, if you want to double R1, the numerator will become double, but the denominator is R1 plus R2, that will not double. So by increasing R1, V output will increase, and by decreasing R2, V output will also increase. So doubling, if we, let's see option A, R1 is doubled, R2 is doubled. If both are doubled, there will be no change in the output voltage. If R1 is doubled and R2 is reduced, that is half, then this voltage will increase. Okay, so B is correct option. Now we have completed one paper, 1-1, and we will move to the second paper. Point 2, a fine mist of oil droplets is sprayed into air. As the oil droplets leave the nozzle of the spraying device, they can become electrically charged. What is not possible value of a charge on an oil droplet? This question relates to the quantization of the charge. You know, elementary charge is 1.6 times 10 power minus 19. And any charge should be whole number multiple of this charge. Okay. So we can multiply 2 with this charge. So this charge is possible. That will be equal to the charge of 2 electron. That is 3.2 times 10 power minus 19. So if we are given any charge, and if we divide that charge with this charge, and we get a whole number, then that charge is possible. This B, zero charge, if it is a charged particle, then zero is not possible. If oil droplet is charged, then zero is not possible. Is this charge possible? As I have already told you, the minimum charge, the elementary charge is 1.6 times 10 to the power minus 19. The charge less than this charge is only possible on the quarks, that is 2 by 3e, 1 by 3e. But any other objects will have charge greater than this charge. We can remove a whole number of electrons or add whole number of electrons to the substance. So any charge will be in whole number multiple of this charge. So that's why 1 into 10 power minus 19 is not possible. What about 4.8 times 10 power minus 19? We will see, is the 4.8 times 10 power minus 19 a whole number multiple of this number? If you divide this with this number, you will get 3. So this charge is possible. It's the charge of 3 electron. The charge on electron is negative, but the value is 1.6 times 10 power minus 19. What about this 8 time? This charge is possible. So we are working for the charge that is not possible. Okay. That is not possible value of the charge. So C is possible. C is C is possible. 8 times 10 power minus 19 divided by 1.6 times 10 power minus 19. This charge is 5 times this charge. If you multiply 1.6 times 10 power minus 19 with 5, you will get this charge. So this is also possible. So we are looking for the charge, the value of charge that is not possible. So the B is correct in this case. Please be careful about this word not. In the circuit shown, a fixed resistor X is connected in series with a battery and the variable resistor. So what do we have? We have battery and a fixed resistor and a variable resistor. These two resistors are connected in series. A power dissipated in resistor X is 7.2 watt when current is 3.0 ampere. The variable resistor is adjusted so that its power dissipated is increased by 50%. What is the new current in that circuit? So we know which formula are we going to use for it. The power is, we are given current. So, and we are given current. So which formula we will use? We will use I square time R. We will try to find this resistor X first. So the power is 7.2 watt. I is 3, time resistance is X. So find X from this equation. That is 7.2 divided by 9. Now, if the power has increased by 50%, what should be the new power? You know from your O level about percentage increase. So if 7.2 is increased by 50%, that will be 50% of 7.2 plus 7.2. This is new power, which is 7.2 plus 3.6. So new power is 10.8. Okay. So we will use new power that is equal to I square into R. We know new power, which is 10.8, and we have to find current. We know its resistance R, which is X. So we will put this value over here. That is 7.2 divided by 9. So we will get a value of I from this expression. So the B is the answer for this question. You will calculate it and you will find the solution. The potential difference across a metal wire is kept constant. The length L and diameter D of the wire are both varied. The type of metal is kept the same. How is the current in the wire related to L and D? This is a very important question. We have to find the expression of current in terms of L and D. So how can we get? We know that resistance is related to L and diameter is R is rho L divided by A. Length is L. Area is pi D square by 4. This 4 will come here. This is how resistance is related to L and D square. So potential difference is kept constant. Now we know V is equal to IR. If potential difference is kept constant, and we can see how the current is related to R. So we will make this, put this value of R from this expression over here. You will get I times 4 rho L over pi D square. Now let's make this I subject. So V times pi D square divided by 4 rho L will be equal to I. Now, this final expression will tell you your answer. The current I is related to, the current is inversely proportional to L and directly proportional to D square. The current is inversely proportional to L and directly proportional to D square. A student sets up a circuit. The circuit diagram shows how the positive and negative terminals of the voltmeter are connected to the circuit. The voltmeter has initial reading that is positive. This is voltmeter, you can see. If that measures the potential difference between these 2 points, let's call it A and that is B. If that indicates a positive reading, then the voltage at A must be greater than voltage at B. Which changes, if any, in the temperature and the light intensity will cause the voltmeter reading to decrease. So we want to, the voltmeter reading will be equal to VA minus VB. We want to increase this V, so there are 2 possibilities. Either you can increase this with or you can decrease this. So let's discuss this first one. If you want to increase VA, these 2 resistors are connected as voltmeter has infinite resistance and draws no current. So these 2 resistors are connected in series and these 2 resistors are also connected in series and they both are parallel with this source. So if you want to increase this VA, then we can increase this resistance or we can decrease this resistance. So this is thermistor and you know the resistance of this thermistor will change if the resistance will decrease if the temperature is increased. So we want to increase this resistance. So that's why temperature resistance of thermistor decreases if temperature is increased. But we want to increase this resistance. So if we want to increase this resistance, then temperature should decrease. Then temperature should decrease. So these 2 are not possible. These 2 options are possible. And other thing is, we want to decrease this voltage VB. So this voltage can be decreased by increasing this sorry, decreasing this resistor or increasing this resistor. We have this resistor as fixed value, so we will decrease this resistor to increase this voltage VB. So this is light dependent resistance, and its resistance will decrease if the light intensity is increased. So if we increase the light intensity, its resistance will decrease. As a result, the voltage across this resistor will increase. Okay, so the light intensity should decrease. The light intensity should decrease. That's why D is the right option. Even if you don't have any idea about, you know, this resistor, the temperature should be decreased. So you have eliminated these two choices and you have to pick one out of these two. You can see the light will have effect on this resistor. As a result, it will affect this voltage as well. So the no change option will be eliminated. That's why both should be decreased. Both should be decreased. Wait a second, let me again explain. What do we want? We want to, oh, we want to decrease this voltage. I'm sorry, I figure out the option to decrease this voltage. What we wanted to do, we wanted to decrease this voltage, VA minus VB. We can decrease this voltage by decreasing this or increasing this. So we want to decrease VA. If we want to decrease this voltage across this, we should decrease this resistance. And that resistance is decreased if temperature is increased. If temperature is increased. So this is possible. And we want to increase this voltage. So that can only be possible. We want to increase this. So we should decrease this resistance. So that decreases when the light intensity is increased. So I'm sorry, A is the right answer. I just misunderstood the statement. I did it for to increase. If we wanted to increase this voltmeter reading, then our option would be D. But in this case, we want to decrease this voltmeter reading. Some resistors and battery of EMF E and internal resistance, negligible internal resistance, are connected in series as shown. These are four resistors, they are in series. Which statement is correct? EMF across each resistor equals to the potential difference across the battery. You know, EMF is always of the source and the potential difference is across the resistor. These resistors are unconnected. So that's why EMF across each resistor is not equal to the potential difference. Across each resistor, the potential difference is always. So if it is this statement, sum of potential difference across each resistor is equal to EMF, then it would be a correct option. Sum of potential difference across the resistors is equal to EMF of the battery. As internal resistance is negligible, there is no drop within the battery. So these resistors are connected in series. So the sum of potential difference across each resistor, V1, V2, V3, V4, this is application of Kirchhoff's second law. Kirchhoff's first law is a consequence of conservation of which quantity? You should tell me. Okay, it is first law, so it is conservation of charge. The diagram shows a network of resistors. Each resistor has a resistance of 6 ohm. So what is the total resistance between these 2 points? You should think about this question. These 3 resistors are connected in parallel and each of them have equal value. So what is the total resistance of these 3 resistors? That is 6 divided by 3. 6 divided by 3, which is 2 ohm. And these 6 resistors are connected in parallel. So what is the total resistance of these 6 resistors? As they have equal value, so it is 6 divided by 6, which is 1 ohm. These 3 resistors are connected in parallel and they have equal value. So what is the resistance of these 3 resistors? That is 6 divided by 3, which is 2 ohm. Then this resistor and this resistor single and that one will be in series, which is 2, 1 and 2. What is the total resistance between X and Y? Excellent. It is 5 ohm. These 3 resistors will be added. Very simple question. In the circuit, a battery of negligible internal resistance is connected in series with a pair of fixed resistors R1 and R2. The circuit is to be used to test whether the EMF of the particular cell is 1.5. We want to test if the EMF of this cell is 1.5. The cell is connected between the terminals X and Y in parallel to R2. You can see from the diagram in series with a galvanometer. Which statement about the test is correct? You know, the EMF of this cell is obtained when there is zero deflection in the galvanometer. Then that will show the potential difference across this resistor will be equal to the EMF of this cell. What is the potential difference across this R2? As in this condition, where the deflection of the current is zero, no current will flow through the galvanometer. So these 2 resistors will be in series. And the voltage across R2 will be equal to 20 by 80 times 6. Why did I use 80? Because 20 and 60 are in series. So this is voltage across 20 ohm, which is 1.5 volt. So if the cell has EMF of 1.5 volt, then galvanometer will show zero deflection. If the cell has EMF of different than 1.45, sorry, let's say it has 1.6, then the potential difference across these points will not be same and the galvanometer will show some deflection. So we want to check if a cell has EMF of 1.5 volt. That is only possible when galvanometer will show zero deflection in this circuit. Which statement about the test is correct? A non-zero reading on the galvanometer means cell has an EMF of 1.5. No, a zero, if there is non-zero reading on the galvanometer, then that will show the potential difference across these 2 points is not same the EMF of this battery, and that will not show that will not mean that EMF of this cell is 1.5. So that's why A is incorrect. What about B? The battery doesn't need to have EMF of 6 volt. If this voltage will not be equal to 6 volt, then the potential difference across this R2 will not be equal to 1.5 and this circuit will not be able to test the EMF of 1.5. The cell may be connected either way around the X and Y. So if you switch the terminals of this cell X, then this circuit will not be, then this galvanometer will not be able to show zero deflection because potential difference of this point, these 2 points which should these two battery, this battery and this, the polarities of the E potential difference across this resistor will uh, will add up. So the zero deflection case will not be possible. The galvanometer doesn't need a scale calibrated because we are using this galvanometer over here to detect the current, not to measure the current. So that's why in case of zero deflection, doesn't mean it doesn't matter if it is calibrated for current or not. So we are using galvanometer over here for deflection of the current. So this is the third paper, October number 2023, paper 13. What could not be used to create an electric current? Could not. This not is very important. Please underline this. Alpha particle can be used to create electric currents because they have charge. If alpha particles are made to flow in some region, then there will be current. Beta particles also have charge. Neutrons don't have any charge, so that's why they can't be used to create electric current. Protons have charge, so proton can also be used to create electric current. What is the definition of potential difference across a component? You know, potential difference is energy per unit charge. Energy transferred per unit charge. Very simple and straightforward. The resistance of a filament lamp increases as the current is increased. Why does this happen? Why does the resistance of filament lamp increases with increase in current? If current is increased, then the temperature of the filament lamp will increase, so resistance will also increase. A battery of EMF 12 volt and negligible internal resistance is connected to fixed resistor, this and RT thermistor. Initially, the temperature of the thermistor is 15 degrees centigrade, and the current in this circuit is 0.1 ampere. The temperature of the thermistor is then changed, which causes the current to increase. So I will ask you, is the temperature of the thermistor is increased or decreased? So you should compare these two currents. If the current is increased, that shows this resistance should be decreased. And if the resistance is decreased, then temperature and resistance of thermistor are related by this graph. If the temperature is increased, its resistance should decrease. And as the current has increased, its resistance should decrease. That means the temperature of the thermistor should be increased. So these two are not possible. What about the resistance of this thermistor? We know the total new current. And in this circuit, these two resistors are in series, and the current is this total voltage EMF divided by these total resistance 40 divided by resistance of this thermistor. And we know this current, that's why we can find easily the resistance of this thermistor. And if you calculate this, you will get 60. You can easily calculate 40 plus RT is equal to 12 divided by 0.12, which is equal to 12 divided by 0.12. So what should be the value? This is new current. The current is increases to. This is not increased by. This is increases to. Okay. So we know new current, and new current is this voltage divided by its resistance. So what should be the resistance at new temperature? That is, I think 12. This will be, what is 1200 divided by this? This is 100. So RT will be equal to 60. So that's why A is correct. This is again a very interesting question. I will advise you to read it and try to do it by yourself. A cell of EMF 3 volt, an internal resistance of 0.5 ohm is connected to a variable resistor that you can see in the diagram. This ammeter and voltmeter are connected. The reading on the ammeter I and the reading on voltmeter are recorded. Which graph shows how does V and I vary? So what's the relationship between V, I, and E? You can see using Kirchhoff's first law, this EMF of the circuit is 3, and that is equal to I into 0.5 plus the voltage across this variable resistor. So this variable resistor, if we make this V subject, we will get 3 minus 0.5 I. So looking at this equation and these graphs, you can see if the current through this circuit is 0, the voltage across the voltmeter reading should be 3. If the current is 0, the voltmeter reading should be 3. So that's why this A is not possible. If current is 0, the voltmeter is not 3 over here. So that's why D is also not possible. So let's eliminate these two. So in both B and C, the voltage across this resistor is 3 when current is 0. So how to pick one out of these two? We will look at the second factor. You can see if we put this voltage V0, then what should be our current? That is 0.5 I is equal to 3. So I should be equal to 3 over 0.5, which is 6. So when voltage is 0, the x-intercept of this graph should be 6. So over here, the x-intercept is 0.5. Over here, the x-intercept is 6. So that's why C is correct option. You can also find using the gradient of this graph. If you compare this equation with the equation of straight line, which is y equal to mx plus c, V is equal to minus 0.5 I plus C. C is 3. So the gradient of this graph should be minus 0.5. The gradient of this graph is 3 divided by 0.5, which is not equal to 0.5, which is 3 divided by 6, that is 0.5. Question 35. We are given these three resistors and they are connected in parallel with the cell. The EMF of the cell is V naught. Sorry, this is not EMF. This is potential difference across the cell. And there is no indication about the internal resistance. So we can't assume that internal resistance is zero. If internal resistance is zero, then voltage across the cell is equal to EMF. But in this case, this is voltage across the cell. Which equation can be obtained using Kirchhoff's second law? What is Kirchhoff's second law? That states in a closed loop, sum of EMF is equal to the sum of potential difference. And what is Kirchhoff's first law? At a point, the sum of current entering to a point is equal to the sum of current leaving that point. So these three resistors, V1, R1, R2, R3 are connected in parallel. So voltage across all of these three resistors is equal to this voltage V0. So that's why V0 is equal to V1, V2, and V3. What's the relationship between these current? This is I0, and at this point, I1 is going in this direction, and the current going in downward direction is the sum of these two currents. So I0 is equal to I1 plus I2 plus I3. If in the question the statement was Kirchhoff's first law, then our option B is correct. But in present case, we are given about Kirchhoff's second law, so V0 should be equal to V1, V2, and V3. Three resistors, each of resistance R, are connected in the network as shown. The total resistance between X and Y is 8. So we are given total resistance. We have to find this resistor R. So very simple question. So I recommend you to think about this question. These two resistors are connected in series. So the resistance is 2R. This 2R resistance will be connected in parallel with this resistor R. So their total resistance will be product 2R times R divided by 2R plus R. This is total resistance between X and Y, which is equal to 8, and that is 2R square divided by 3R. Hence, 8 times 3 divided by 2 will be equal to R. So R is 12 ohm. The resistance of each of this resistor is 12. If this is 12, these 12, 12, that will be 24. So 12 and 24, if they are calculated in parallel, we will get this add-on. The potentiometer and the divider's driver cell. This is driver cell, and this is galvanometer. This is mu cell, and this is high resistance wire that is shown with a bold. And these other portions of wire have zero resistance, negligible resistance. The sliding contact is moved along a resistance wire QR until the reading on the galvanometer is zero. If the reading on the galvanometer is zero, then the potential of these 2 points is same. In other words, potential drop across these 2 points and the EMF of the cell is same because this point has the same potential. What is essential requirement for the EMF of the new cell to be measured accurately? The first essential requirement is that the EMF of this new cell should be smaller than the driver cell. The EMF of the driver cell must be less than the EMF of the cell. This is not possible. Then you will not be able to achieve this null point or zero deflection. The voltage, if the voltage of this driver cell is smaller than this cell, then the voltage across these 2 points can't be equal to this EMF of the cell. that will always be smaller than this EMF of the cell, and the galvanometer will not show zero deflection. Galvanometer must have large resistance. No, uh, this galvanometer is connected in series with the cell. Okay, so if it has very high resistance, then what will happen under zero deflection? Under zero deflection, the voltage across this and this will be same, and there will be the resistance of this galvanometer will not matter. So we are using this galvanometer for zero deflection point. Okay. So the internal resistance of the new cell must be zero. Even if this new cell has some internal resistance, it will not affect this method, because when the current through this part is zero, there will be no drop across this internal resistance, and that is the advantage of using this method. So for zero deflection mean there will be 0 ampere current flowing through this circuit, and this resistance will not matter. The resistance per unit length of the wire QR must be constant. If this has zero deflection at this point, then the resistance of this portion of the wire, the voltage across this portion of the wire is equal to the EMF of this cell. So L1 over this total length of the wire multiply by the EMF of this driver cell is equal to EMF of new cell. If the resistance per unit of the wire is not constant, then we will not be able to use this expression. Okay. So then the D is the essential requirement for this question. The electric current in a wire is this 4 milliampere. How many electrons pass in 10 hours? This is a new question. We are given electric current, that is charge divided by time, and we know that this charge is number of electrons multiplied by the elementary charge, that is charge of electron divided by time. So we have to find number of electrons, that is equal to I time t divided by elementary charge. So I is 4 times 10 power minus 3 ampere. Time is 10 hours. Hours mean 3600 seconds divided by elementary charge is 1.6 times 10 power minus 19. So you will get the answer of this will be 9 times 10 power 20. What is the definition of the potential difference across the electrical component? Potential difference is energy transferred per unit charge. Force per unit charge, resistance per unit charge, charge per unit time passing, charge per unit time passing through a component is current. The energy transferred per unit charge. Which graph shows IV characteristics of filament lamp? Filament lamp resistance will increase if voltage is increased. And in all of these graphs, I is on y-axis and voltage across x-axis. So gradient is 1 over R. So R is equal to 1 over gradient. Okay. So to increase this R, gradient should decrease. And in option D, the gradient is decreasing. You can see the gradient is decreasing. This is graph of resistor. That is graph of, in this case, the resistance is decreasing. Okay, so that could be the graph of diode. A metal wire has a length of this and cross-sectional area of this. So length of the wire is given and cross-sectional area of the wire is given and resistivity of the wire is given. The wire is now stretched so that its length increases to this is new length and the wire remains cylindrical and the volume of the wire remains constant. What is the change in the resistance of the wire? So we have to find the change in resistance. You know, resistance is rho L divided by A. So the volume of the wire is constant. We have to convert this expression in terms of volume. The length of the wire is changed and the volume of the wire is kept constant. So volume of the wire is cross-sectional area of the wire time length. So we cross-sectional area of the wire time length. So the area is volume divided by L. Resistance will be rho. We have to find the change in resistance. So the lengths of the wire are changed and resistivity is known. Resistivity is known, area is known, length is known. So we can find initial resistance. We are given new length and the resistivity is same and the new area we can calculate. If the volume is same, using the original expression, area time L will give us volume. So we can find volume from this first condition. Okay. Then keeping the volume same, we will have to find the new area. We are given new length, so we can find volume is same, area new, length new. So we can find new area. So using that new area, we will find new resistance and we will find the difference of these two resistors to find the change in resistance. I hope you got my points. So the answer of this is, let me check the answer. B. Your answer should be B. These are the steps. Find the volume first, and then using the same volume, find the new cross-sectional area. So using new cross-sectional area, new length, the resistivity is same, find new resistance, and then find the change of the resistance. Which circuit symbol represents microphone? So the symbol of microphone is this. This is symbol of the speaker. This is symbol of the buzzer, and that is the symbol of electric bell. 35. A battery with internal resistance is connected to a fixed resistor, ammeter and voltmeter. So voltage across this resistor is V is equal to EMF E of this battery plus I into R. What are the conditions of this circuit? The battery is replaced with a different battery and has the same EMF. So EMF is kept same. Internal resistance R is increased. If you increase this internal resistance, what happens to the readings on ammeter and voltmeter? If the internal resistance is increased, keeping this E same, the overall resistance of the circuit will increase, causing to decrease the current in the circuit. So the current in the circuit will decrease. And if the current in the circuit is decreased, the voltmeter reading, that is V is equal to IR. If current is decreased, the voltmeter reading will also decrease. For potential divided circuits, each consists of a battery. You can see All of these circuits. What do we want? Which circuit has the largest output voltage? We want largest output voltage. These two resistors are in series, so they have equal value. What is the resistance of, what is the voltage across this resistor? That will be 9.5 volt, sorry, 4.5 volt. That is half of this voltage. This resistor has resistance 2x divided by total resistance, which is 3x, multiply by 9 will give you V. So 6 volt. What is voltage across C? First find the equivalent resistance of these two. That is x times 2x, x plus 2x, product over sum. This is 2x square over 3x, 2 by 3x. So we can replace the circuit by this simple circuit, x, and that is 2 by 3x. So what is voltage? V output will be 2 by 3 x divided by 2 by 3x plus x times this 9 volt, which is 2 by 3x divided by 5 by 3x multiply by 9. So that is 18 by 5. 18 by 5, 18 by 5 is 3 point something. What about this voltage? That is 2 by 3 x. This is similar to this. The resistance of these two is 2 by 3x. So what about voltage? That is x over 2 by 3x plus x times 9. So 9x divided by 5x by 3. So that 3 will go up, 27 divided by 5. So that is 5 point something. So 36, B is the correct option. We wanted the greatest value of this output voltage. That is only possible when this X is the greatest, okay, as compared to these two resistors. This is very important question. A voltmeter is connected into a circuit with the battery shown. Many students stuck in this question. The sliding contact is moved to end P. This is sliding contact. That is moved to end P of the potential, and then this is moved to this end Q. What are the two readings of the voltmeter? So let's draw two different circuits using these two conditions. This is the resistor, that is Q, and this is P, that is voltmeter. This is this one. So this is positive of voltmeter, that is negative. So what is the reading on the voltmeter? How can we find this? We will use Kirchhoff's second law to find the voltage across this voltmeter in this loop. Okay, so the sum of EMF in this closed loop, you can see there is only EMF of 3 volt, which is 3. Sum of EMF is 3. If I start from this point and I move in this way, then I put a sign convention, low to high, I give negative sign, high to low, positive. I go in this way and I move from low to high, that is -3. Then I come and then move from here to here, that is high to low, which is positive voltage V. equal to 0. That is the application, that is direct application of Kirchhoff second law. So V is equal to 3. Voltmeter reading is 3 in this case. Now, if we move this circuit point to the new position, let me draw a new circuit. This point is connected here. This is positive, that is negative. 3. This is also 3. So, which loop should we use? We can use, there is very infinite resistance of the voltmeter, and voltmeter draws no current. So we can use either this loop or the inner one loop, that one loop, to find the voltmeter reading. So let's start from here and move in this way using the same sign convention. The first we will get low to high, that is -3. Then we will go in this direction, that is also from low to high, that is -3. And then in this part, from high to low, which is positive V, is equal to 0. So V is equal to 6 volt. This is very important question. So we used Kirchhoff's second law in both of these situations. Which charge can be carried by charge carriers? We had already done the similar question. So you should do it. The charge, elementary charge is 1.6 times 10 power minus 19, and any charge must be integer multiple of this charge. 4.8 is times 10 power minus 19 is 3 times this elementary charge. So that is possible. These all three charges are not possible. Resistor R is connected across a cell of EMF E and negligible resistance. Which single change to the circuit would lead to the largest increase in the power dissipated in the resistor? So power is EMF square divided by R. We want to increase this power. And if we double this E, this is our original power. Then the new power is, if we double E, 2E whole square, that is divided by R is kept same. So 4E square divided by R, this is original power. This new power is 4 times E square by R. Let us check this second. Doubling the value of R will reduce the power further. We want to have the largest increase in power. So that will decrease the power. So this is not possible. Halving the value of E, if you half the value of E, that will further reduce the power. So that is also not possible. If you half the value of R, that will increase the power. But in this case, that is 2E square divided by R. Let's compare these two values. In this case, power is increased by 4 times. In this case, the power is increased by 2 times. So option A is correct. An electrical cable is made up of one thick strand of the copper wire that is surrounded by 8 thin strands of copper wire. These are thin copper wires, and that is thick copper wire. And their cross-sectional areas are given. They have the same length. that is L. Cable has total resistance is given. You can see these, all of these 8 wires and this large wires are connected in parallel. So the total resistance will be equal to, what's the resistance of this single wire? That is rho L divided by A. Single wire, rho L divided by A, that is the resistance of one single wire. Let me call it R1. And there are 8 wires. So resistance of R of these 8 small wires will be, they are connected in parallel. So that is rho L divided by 8A. If two wires of equal resistance are connected in parallel, then their resistance is half of that single resistance. If there are 8 wires, then resistance will be 1 by 8 of the resistance of single wire. And this is the total resistance of these 8 wires. And the resistance of this large wire is rho L by 4A. Now this resistance and that resistance are also parallel. So the total resistance will be rho L by 8A parallel to rho L by 4A. So that is product over sum. Rho L by 8A times rho L by 4A divided by rho L by 8A plus rho L by 4A. So we have to find rho as the subject of the formula. So let's simplify numerator, rho L square over 32A square divided by, if we make the common denominator, that will be 2, that will be 8, 3 rho L by 8A. That is rho square L square by 32 times A square time 8A divided by 3 rho L. Now you can simply say, cancel these things. So R is rho L by 12A. We had to find the resistivity, that is 12A R over L. 12AR over L. So the D is the right answer. This is very interesting question. A car has sensors for detecting the light intensity and the temperature of its environment. The sensors make use of light LDR and thermistor. The car moves from warm to dark environment. No, the car moves from a warm and dark environment into cold and bright environment. So temperature is decreased and the light intensity is increased. Okay. So if temperature is decreased, if light intensity, if the light intensity is increased, the resistance should decrease. The resistance of LDR will decrease if as the light intensity is increased. So that will decrease. What about thermostat? Temperature is decreased, so its resistance is, temperature is decreased, resistance will increase. So C is correct option. A student assembles the circuit shown. There are three diodes and two lamps. Which row describes the state of two lamps? You know, if a diode has high voltage in this side and low voltage on this side, it will conduct. As this side is connected to this high terminal of the potential cell, so this diode will conduct and this lamp will be on. Over here, this diode will conduct and that will not conduct. But they are connected in parallel. So current will flow in both of these two diodes through this way. So both of the lamps will be on. So D is correct option for this question. Kirchhoff first law is the consequence of, this is a repeated question. First law is consequence of the charge. This is again a different question. You can think about it. There are three identical cells, each have EMF E, and three identical resistors, each have resistance R. What is the potential difference across one of the resistors? So let's use Kirchhoff first law, Kirchhoff second law. In a closed loop, sum of EMF is equal to the sum of potential difference. So let's start from here and move in this way. The direction of current is not given. So we can assume any direction of the current, that will not matter. Let's say that is the direction of current. And we are going in this way. We are going in the direction of current through resistors. So voltage across each of these resistors will be same. And we are going from high to low. Let's say this is V and that is positive. And then from high to low, that is E in this case. Then from high to low, that is V. Then from high to low, that is E. Then from high to low, that is V. Then from low to high, that is minus E is equal to 0. So the voltage across each of the resistor is what is voltage across each of the resistors? V is equal to minus E. So V is equal to E divided by 3. What does this negative sign shows? We have assumed self-direction of the current, so that's why the actual direction of current is the opposite of the direction we assume. So E by 3 is the answer. Another way of doing this question is, you can see this negative sign is connected to this positive. So these two batteries support each other and this is opposite to that. So the total EMF of the circuit is 2E minus E, which is E. Total EMF of the circuit is E and total resistance is 3R. So is E is equal to 3 times V. So V is equal to E by 3. This is power supply and sliding contact uniform metal wire. The galvanometer reading is non-zero. That shows the voltage at this point is not equal to voltage at that point. And this point is not in the middle of the wire. The light dependent, oh, sorry. Initially, initially the ammeter reading is 0. So voltage across A is equal to voltage across B, these 2 points. But when this is covered, no light hits this resistor. So then this has non-zero voltage, non-zero reading. So what change will bring this ammeter reading to 0? You know, resistance of LDR decreases as light is increased. But over here, the light intensity has decreased as it is covered. So resistance of LDR will increase. If resistance of LDR has increased, then voltage of this point A will not be equal to voltage across point B. Okay. So if we consider this as a reference point, ground, then voltage across this resistor was equal to the voltage across this part of the wire. But now as the LDR resistance has increased, causing to decrease this voltage VA. VA is the volt, no, I'm sorry, not causing. If we are considering this as a 0 point, then the voltage across this point A is the voltage across this LDR. So the voltage across this VA has increased. Now VA is greater than VB. So what can we do? We have to increase voltage across this VB. That is only possible if we move this sliding contact to the left, then the length of this part will increase, causing to increase this voltage and achieving the null point. So C is right option. A metal wire is connected between the terminals of a cell so that there is a current in the wire. Which statement is correct? Negatively charged electrons in the wire move from negative terminal of to the positive terminal. Metal wire, terminals of the cell. This is wire, and that is connected in the cell. Where does electron move? Electron move from the negative terminal to the positive terminal. So that is straightforward question. Negative charge electrons in the wire move from the negative terminals to the positive terminals. Question 12, R to R, what is the value? The total power dissipated in this. We have already done this question. Power is V square divided by R total. So power is 12 square divided by R total. First find R total. Then using the parallel formula, you can find this R. That is very simple question. So power is 36. 12 square divided by R total. So R total will be 12 square divided by 36. And R total in this case will be product over sum. So 2 by 3 R is equal to R this total. You will get the value of R. That is equal to 6. A wire has a length of this and made of metal of the resistivity. We know resistivity of the wire and the length of wire. Potential difference, we know this V, and current is also known. What is the cross-sectional area of the wire? R is rho L by A, and you know V is equal to IR. So R is equal to V by I. So we have to find cross-sectional area of the wire, that is rho Li divided by V. Just put their values: meter, ohm meter, volt, area. What is the cross-sectional current? What is the cross-sectional area of the wire? You will get that. So the answer is B. A cell of negligible internal resistance connected in series with the thermistor, fixed resistor, and ammeter. Thermistor is placed in a beaker of water and the temperature of the water is slowly increased. Okay. If temperature is increased, then resistance of thermistor will decrease. Which a graph of current against temperature is plotted. So how does the current change with temperature? Please think about this question. As temperature is increased, resistance should decrease, causing the increase in current. If resistance is decreased, according to V is equal to IR, current will increase. So there is only one possibility where current is increasing, that is V. At zero temperature, there is some resistance, that is least resistance. So current, sorry, at zero temperature, the resistance is maximum, so current is minimum. 34. Look at this question. Initially, the switch is open. These two resistors are in parallel. And this is, you can see the circuit. What happens to the voltmeter and ammeter reading when the switch is closed? If you close the switch, what happens to overall resistance? These two resistors are in parallel, so overall resistance will decrease. Adding a new resistance in parallel with the previous resistor will decrease the resistance. So as the resistance of overall circuit is decreased, then the current will increase. So ammeter reading will increase. What will happen to the voltmeter reading? This voltmeter shows the voltage across the terminals of the battery, that is the voltage across these two resistors. And now the voltage V is equal to E minus IR. Okay. So if current has increased, then this voltage will decrease. So voltage will decrease, current will increase. Kirchhoff's first law, the sum of currents in two junctions is equal to the sum of currents leaving. The law is based on the conservation of, very simple, has been asked many times, conservation of charge. Two resistors have combined resistance when connected in series. So connected in series mean R1 plus R2 is equal to 34. The same resistors have the combined resistance 7.4 when connected in parallel. So product over sum is equal to 7.4. Solve these two simultaneous equations to get the value of R1 and R2. You can do that. The answer would be C. What about 37? The EMF of the cells is known to be approximately 0.5 volt. This. So internal resistance this 2 volt. You can see driver cell 2 volt. Sliding contact is moved along the uniform resistance between Q and R. Okay. Where the reading of the galvanometer is 0. What is the expression for the approximate length of this? So this voltage is 0.5. If the galvanometer shows 0 reading, then the voltage across this part of the wire is equal to the voltage across this source. So voltage across this part of the wire is, let's say this is V1. V1 is, as galvanometer shows 0 deflection, so this part is in series. So V1 is equal to the length of this wire QP divided by length of this wire QR time this voltage 2. So V1 is 0.5 and we have to find QP over QR. So QP is 0.5 time QR divided by 2. So that is 1 by 4 time QR. So 37 option A is correct. A wire carries a current of this. The potential difference across the wire is this. How much energy is dissipated by the wire in time this? So energy is power into time and current and voltage are given. So power is VI into T. So voltage is 10 millivolt time current is 0.1 time 10 power minus 6 time is 10 second. So you will use this to calculate this. So the answer is D. You will convert in nanojoule. This is 10, 10, this will cancel out. So 10 time 10 power minus 9. That is 10 nanojoule. What is the definition of potential difference? Energy transferred per unit charge. Extremely tired, yes. The table shows components of two different wires P and Q. P length, resistance and resistivity, length, resistance, resistivity. P has cross section of diameter D. What's the diameter of the other wire? Q. Resistance is rho L over area pi D square by 4. Okay. So P has resistance diameter D. Resistance is 4 rho L by pi D square. What I am doing? Resistance is 4 rho L over pi D square. So what is the resistance of the wire P? R. What is the resistivity? Rho. What is length? L and pi D square. What about Q? We have to find the resistance of Q is R by 4. Resistivity is rho by 3. Length is 2L divided by pi D of Q square. So we have to find this dq as a subject and then use this expression to convert this new d in terms of the previous d. You can do that. I have extremely tired, so I don't want to do it. I have told you the method. You can easily do it. The answer would be B. A cell has a constant EMF. Variable resistor is connected between the terminals of the cell. The resistor of the variable resistor is decreased. So the cell has constant EMF resistor connected, the resistance variable resistance. What about internal resistance of the cell? So let's assume there is internal resistance and this is variable resistance. So voltage across variable resistor is E minus IR. The resistance of variable resistor is decreased. So IR is equal to E minus IR. If we decrease this resistance, what will happen to terminal potential difference? Terminal potential difference is IR, so that will decrease because more work is done moving a unit charge through the internal resistance. Current will increase, so more power will be dissipated across internal resistance. Very simple. First law is conservation of charge, second law is conservation of energy, so 35B. You can see the circuit, EMF, internal resistance, current through this resistor, that resistors are given. We have to find R, this R, and that R. How can we do? These two resistors are in series and they are parallel with this resistor. So we can use this loop, external loop, to find this R. The EMF is 10, 0.48 times 15 plus current through this resistor is not 0.48, that is the sum of these two, 0.48 plus 0.45, 0.93 times this R, you will get this R. After obtaining this R, you can use this loop to find this resistor R. So the answer is A. 37, the last question of this series. A battery of negligible internal resistance is connected in series. Okay, V out. This is thermistor. Temperature 20, resistance of thermistor is 20, 50 pe we are given resistance. The potential difference V out at 20 degrees centigrade is given. That is 4.5. We have to find at 50 degrees centigrade. So at 20 degrees centigrade, its resistance is 12. So this is 4.5. So V output is 12 by 24 times this V input. If this is 4.5, then V input is 9. So this is 9. Then we have to find at 50 degrees centigrade. So the 12 divided by its resistance is 5. 17 multiplied by 9. That will give you EMF, sorry, V output voltage 8, this case, which is equal to 6.35. I have done all the electricity questions of all the variants of 2023, including Feb March. Now you have a better idea of all the questions of all the recent questions of electricity. And if this video is useful for you, then please share it with your friends so that they may also get advantage of my channel. Thank you so much and good luck for your exam.